In this video, we're going to take a look at concentrations in consumer products. So we saw what concentration meant in the last lesson, but now we're going to go into more depth on concentration in terms of a concept, but also in terms of a quantitative construct. So we'll see how to calculate it using various formulas. There's different ways to do it depending on the context that you're in. And we're going to focus on consumer products in this lesson here. So when we take a look at concentration, we talk about it being the amount of solute in a unit volume of solvent or solution specifically. So it's the ratio of solute to the solution there. And this is the general equation. So you put the amount of solute over here over the amount of solution that's present. And you can have what's called a concentrated solution. So as you can see from the picture over here, concentrated solution has a high ratio of solute to solution. So there's a lot of solute packed in here per unit volume of solution. Whereas a dilute solution, so not concentrated, has a low ratio of solute to solution. So it's the same volume as this beaker over here, but there's fewer particles of solute per that unit volume. So you can almost think of it as watered down. So concentrated is, there's still water there, but there's a lot more particles crammed in that same volume of space, as you can see here. And then over here, we have more dilute. There's fewer particles in this volume of space. This is concentrated right now, but you can make it more dilute. And you probably know how. Remember I said watered down. Well, if you add more water, now you have a larger volume of solution. And so technically the amount of solute per solution has now decreased when you add more water to it. So you can dilute a concentrated solution to make it, more dilute. And so here you can see just some mathematical examples of what it would look like on a numerical level. So for example, if we have a concentration of 14 moles per liter, that essentially means you have 14 moles of whatever you're dealing with per liter of solution. And that's more concentrated than something like 0.14 moles per liter. So 0.14 moles of whatever the solute is per liter of solution. Or if you're looking at it in a different expression as a percentage, you can say, for example, 70% mass volume. That's more concentrated than saying 3% mass volume. And so we'll learn what these different units are later on. They're just different ways to express concentration, but essentially the higher the number for a particular unit of concentration, the more concentrated you are, the more concentrated that solution is. So that's what concentration is all about. You should be able to explain the definition of concentration, the general formula for concentration over here, and we'll see this applied in different contexts, so it'll vary a little bit. And the definition of what a concentrated solution is versus dilute, and the idea that it's all about the amount of solute per unit of volume of solution. And you can dilute a concentrated solution to make it more dilute. And then also understand that these numbers do tell you the concentration, and you can compare them to each other to determine if a solution is more concentrated or less concentrated than another, for example. So there's three main ways to express concentration quantitatively. In other words, with numbers, as you can see here, we have acetic acid, 3% volume, and then we see over here 100 ppm. So there's different ways to do it, and these are the three main ways over here. So there's percent concentrations, which are used for consumer products, so things that we typically buy, you'll have in your home. So if you look at a bottle of hydrogen peroxide in your home, you'll see, for example, that it might say 3% VV. Very small concentrations have their own expressions, and actually that's over here, ppm, ppb, and ppt, and we'll take a look at that. And then also molar concentrations, which is what we're going to be focusing on in the lab. So molar concentrations, that's what we'll see in the lab, back to the mole calculations afterwards. But in this video, we're going to focus on the first two methods, concentrations of consumer products, and then very small concentrations. So the concentrations in consumer products are called percent concentrations. And these are basically concentrations that are expressed as percentages because they're just easier for us to understand. Not everyone's a scientist, not everyone's a science background, and so the percentage is just easier for people to get. So here we can see a great example of a percent concentration, 50% by volume for isopropyl alcohol. So basically you have a mixture here of water and alcohol, and 50% of that volume is going to be alcohol. So there's a few different ways to express percent concentrations, and you'll choose the one depending on what your solution is made up of. But essentially you can have percent volume, which is percent VV, percent mass volume, percent MV, percentage mass, percent mm. And notice they're all very similar to each other in terms of the calculation, but it'll just change in terms of what the unit is. So for example, if you're doing percent VV, it's volume of solute in liters over volume of solution in liters as well. Just make sure you're consistent with the unit there. If it's milliliters on top, it should be milliliters at the bottom as well. Your percent MV is your mass of your solute rather than your volume of solute for VV, so mass over volume. So mass of solute in grams, this one has to be in grams, over volume of a solution in milliliters. So this is grams over milliliters times 100%. Over here, we have a percent mass, which is mass of solute in grams over mass of solution in grams times 100%. So you just have to pay attention to what's given to you in the question or in the scenario, and then you can choose which to apply to your situation. So these are the three types of percent concentrations that you'll often find on the labels of many consumer products. So if you look again at alcohol or at vinegar, you'll see, for example, here we have 5% acidity. So most likely this is a 5% volume, and we'll take a look at how we can figure that out. So here we have the types of percent concentration summarized on one slide. The formulas are here provided to us. As you can see, mass is in grams and volume is in milliliters. As long as you're consistent, essentially, when we're over here, this is in grams and this is in milliliters over here. Here, it's typically liters over liters, but if you put milliliters, make sure it's milliliters at the bottom here. And here it's going to be grams over grams, but let's say you put kilograms, make sure it's kilograms on the bottom here too to be consistent. Here we typically stick with grams over mils. So our percent volume is usually when your solute is a liquid and your solvent is a liquid. So in isopropyl alcohol, which is rubbing alcohol that you might have at home, if we say 70% by volume, that's a volume. You have your solute, which is the liquid, and your solvent, the liquid as well. So essentially this 70% by volume would mean in this isopropyl alcohol here that 70 mils out of every 100 mils solution in your bottle is isopropyl alcohol. That's what that would mean. And then the rest is water. So over here, our percent mass volume is when your solute is a solid and your solvent is a liquid. If you look at bleach will say 6% sodium hypochlorite. What that basically means is for every 100 milliliters of solution that you have, 6 grams is going to be sodium hypochlorite in the bleach. And then you can have your mass, your percent mass, which is when you have two solids. So you have your solute solid and your solvent is solid. So if you look at this cream over here, benzoyl peroxide, it's an ingredient in a lot of acne creams, and you'll see the concentration is 5% mass. So what that basically means is 5 grams of the active ingredient, benzoyl peroxide, is going to be in every 100 grams of solution. So 5 over 100 times 100%. And so that's when that's how you would know how to apply the different percent concentrations. So if you have two liquids, basically percent volume for the most part. If you have a mass or a solid and a liquid, so solute that's solid and solvent is liquid, use a percent mass volume. And if you have a solution where it's two solids, so solute solid, solvent is solid, then use your percent mass. And so it's great to review these examples so you understand what those percentages mean when you're looking at your the products that you have in your home. So start by reading these examples here, understand the equations, and what we'll do is we'll go and we'll try to apply this concept to some calculations. Just a few reminders before we go into calculations. You do need to convert sometimes your various units. So remember that 1 liter is 1,000 mils. And remember, you can also have mass conversion factors. So 1 kilogram is 1,000 grams and 1 gram is 1,000 milligrams. So to go from kilogram to grams, for example, you would multiply by 1,000, right? 1 to 1,000 is multiply, and then the reverse is divide. So make sure you review that if you're not 100% sure on how to do your conversions. Remember, when you go from liter to milliliter, you multiply by 1,000, but then going the other way, you divide by 1,000. And then for gram to milligrams, you multiply by 1,000, and then to go the other way, milligrams to gram, you divide by 1,000. So there's just some reminder conversion factors you might need in this unit because we'll be dealing with volumes and grams quite a bit. So in the next video, we're going to take a look at how to do these calculations. Before we finish this video off, let's go ahead and just fill in some blanks to make sure we understand the concepts. So as we went through the slide deck, we saw that concentration is your ratio of solute to amount of solvent or solution. Generally, we look at the amount of solution there. we saw that solutions can be described qualitatively, which basically means with words, and we can say something is concentrated or dilute. If we say concentrated, that's a high ratio of solute to solution, so there's a lot of solute packed into a unit of solution, to a unit volume of solution. And then dilute, that basically means that it's a lower ratio of solute to solution, so not as much solute packed into that solution. So an example of this, if you want to draw a diagram out, let's put the same volume. Let's just pretend we have 100 mils in each container here, each beaker. And then over here, I'm going to draw a dilute solution. So I'll just put a few little dots to represent my solute. So this is my solute. And here I'll do a more concentrated solution. So a lot more solute in that same volume. You could dilute a concentrated solution by adding more water or more solvent, for example, and that'll make it spread out more so you have less per unit volume. That works as well. And then we saw some examples, some numerical examples. So there's different units, and it may not make much sense to you right now, but for example, you might have a concentration of 14 moles per liter, which basically means you have 14 moles of solute per liter of solution. And that would be concentrated compared to something like this, which is 0.14 moles per liter of solution. And so that this means you have 0.14 moles per liter of solution instead, which is more dilute than the 14 moles per liter. And we also saw maybe, for example, a percent VV. So if we have a percent VV of, let's say, 70% volume, that's more concentrated than something like this. So percent VV is equal to, let's say, 3% volume. So understand that generally for a given unit, the bigger the number that you see, the more concentrated that solution is going to be compared to other solutions. And then we saw that there were three main ways of expressing concentrations quantitatively, meaning with numbers. We saw there's percent concentrations for consumer products, so things you buy in the store and have on your shelf at home or in your cupboard at home. Very small concentrations. We'll take a look at that as well in this whole overall lesson. And then molar concentrations will be the focus in our next lesson. So we'll start off with percent concentrations, as we saw, and that's for consumer products, where they're usually expressed as percentages, just because they're easier to understand for us. And they're typically found on labels of many consumer products like vinegar and alcohol. You can see that over here, 50% volume by volume, 70% volume by volume there. And we saw the three different types of percentage concentrations here: percent volume, mass volume, and then mass, with the appropriate units. So remember that this is liters and liters, or milliliters and milliliters, as long as you're consistent. Over here we have grams over milliliters, and over here we have grams over grams, or kilograms over kilograms, or milligrams over milligrams, even, as long as we're consistent there with the top. And then times 100%. And we saw that we apply these to different scenarios. So percent volume was our two liquids, mass volume, a solid and a liquid, and then mass, two solids, essentially. The last thing we left off on was some conversion factors that are important to understand. So going from liters to milliliters, for example, you need to multiply by 1,000, and then going the other way around, you need to divide by 1,000. Okay, and it's kind of like your conversion factor, right? So just to show you a quick example here, if you had 2 liters and you want to convert it to milliliters, well, what you can do is you could say, okay, I can make a ratio. I could do 2 liters multiplied by, you can either choose to multiply it by 1 liter for every 1,000 mils, or you could say 1,000 mils for every 1 liter. And so what you want to do is multiply it by the ratio that'll get rid of liters and keep milliliters. So that would be this ratio over here. So times 1,000 milliliters for every 1 liter. You cancel out liters there, and you get 2,000 mils. And when you convert, the number of sig figs should be consistent. So for example, if I had 1 sig fig here, this is 1 sig fig there as well. So keep those significant figures consistent when you're doing your conversions. They shouldn't really be changing. In the next video, we're going to focus on doing some calculations, some examples with the percent concentrations that we saw, seeing some practical examples from your home, and then applying them to the different formulas and calculations that you see here.